Hello, welcome to Prajim Technologies. I am Venkat. This is part 6, Nullable Types in C Sharp. In this session, we will learn nullable types in C Sharp and about null coalescing operator. Now, actually in C Sharp, we can broadly divide the types into two categories, value types and reference types. In our previous module, we have already seen value types, the built-in value types like integer, double, float, decimal, etc. Okay, and we also have, apart from these built-in value types, we also have reference types. We have seen one of the built-in reference type, which is string. String is actually a class. Okay, and examples of reference types include classes, interface, delegates, arrays, etc. We will talk about the differences between value types and reference types in detail in a later session. Okay, at this point what we need to understand is that in C Sharp the types can be divided into two broad categories, value types and reference types. Examples of value types: int, float, double, etc. Examples for value types: classes, interface, delegates, etc. And another point that we need to keep in mind at this point is the default value for reference types is null, whereas the default value for value types is some form of 0. For example, if it's an integer, the default value for any variable of type integer is 0 and they cannot hold null values. Let's actually look at a demo. So for example, I told you string, which is a class, is actually a reference type. So for example, when I say string name equals null, and then if we try to compile this, it will compile without any problem because reference types can have null values. But whereas if I create a value type, for example, integer is a value type, so int I equal to null, and if we try to look at this, we already have got the red squiggly cannot convert null to an int because it's a non-nullable value type. So I is a value type and you cannot initialize that to a null value. Okay, but whereas reference types can have null values. So that's one important difference at this point between value types and reference types. There are several other major differences between these two, which we will be talking about in a later session. Okay, now if I have to store a null value in a value type, how do I do that? Is that at all possible in C Sharp? Absolutely. In C Sharp, the value types can be actually divided into two types again, non-nullable value types and nullable value types. So if we go back to the presentation, so by default, value types are non-nullable. To make them nullable, use question mark. So let me give you an example for that. So here I is a non-nullable integer data type. Now if I have to make this nullable, all I have to do is use a question mark. And now look at that, that red squiggly goes away, which means if you want to make a value type nullable, just put a question mark next to the type. That makes it nullable data type. And why did C Sharp introduce this? There are actually several reasons. One of the reasons is, let's say for example, you have a form like this, where a user has to supply his first name, last name, which are mandatory. But whereas are you a major, this field is optional. And if the options for this are yes and no. Okay, and as this field is optional, he might choose not to answer. If he says, if he didn't answer, are you a major? Then how will you store that value? So let's say for example we have a boolean flag here, boolean are you major in the application. Now this can only be true or false because look at this, are you a major is, we don't have a question mark, meaning it's a non-nullable value type. Okay, so if it's a non-nullable value type and a boolean value can only take true or false, but here if the user doesn't select yes or no, it means he didn't select any answer for this field and this field is optional. So what value will you initialize this field with? Is it true or false? If you if you initialize that with false, it's as if the user has said no. Okay, so we should be in a position to store null values in this variable of type boolean, because are you a major? Yes, no, the user did not answer. There are three options actually. If the user didn't answer, it means he did not select any of the yes or no options for this question. So if he didn't select any of the options, then I should be capable of storing null value. Otherwise, we will not be in a position to differentiate between the user not answering the question and saying no if we store this value as false. That's why these nullable types are so much useful. And another reason why these nullable types are so useful is because, you know, databases does not have the concept of value types or reference types. Whether if it is nvar, integer, whatever is the data type, you can store null in the column of a table in a database for any data type. Okay, but value types and reference types are only C# concepts. Okay, so when it comes to working with C# and databases, we have to have some form of transformation between nulls and non-null value types. But with these nullable value types now, we don't have to do that conversion anymore. Now it makes working with database fields very much easy. So these are some of the reasons why these nullable data types are very helpful in C#. So let's complete this example. So I can make this boolean are you major null. So within this form, if the user does not select yes or no options, then this field will be null anyways. Okay, and let's say for example we want to check if are you major is equal to true. We can say console.writeLine, maybe user is major. You can either say are you major is equal to true, or you can simply say are you major dot value. From the IntelliSense, if you look at this value actually returns a boolean data type, not a nullable boolean data type. Okay, so you can say if it has to be false, so you can either say if this is true, user is major. If not true, user is not major. So you can either say it this way, or you can say it if are you major is equal to false. Either of them will work. And else, okay, keep in mind a nullable boolean data type can hold three different values: true, false, or null. If it is true, we are saying user is major. If it is false, user is not major. If it's not true and if it's not false, the only other option that's available, it could be null. So we can just say console.writeLine, user did not answer the question. Okay, so now we are in a position, if the user didn't answer the question here, yes or no, he didn't select any of these options, then IU major will be null and will be in a position to say user did not answer the question. But in case if we didn't have this boolean flag, we may have to initialize that to false. So in that case, we would not have been in a position to differentiate between the user didn't answer the question or he's not a major. So now if we go ahead and run, since IU major is null, we get that user did not answer the question. Okay, a little grammatical mistake there. All right, on the other hand, if he says true, then obviously user is major. Okay, so that's about nullable types. Even the integer types, you can make them nullable. Okay, all value types, they have they have the respective counterpart nullable types. Another concept that we'll talk about is the null coalescing operator, which is really interesting. Now let's say, for example, I have a field called um, number of tickets on sale equal to, let's say, 10. Okay, I have tickets on sale, and I have another variable, let's call available tickets. Let's say this tickets on sale is a nullable data type, and there are no tickets on sale right now, so which means tickets on sale is null. So if tickets on sale is null, then obviously there are no tickets available. So if tickets on sale is equal to null, then we know available tickets, we want to initialize that to 0. Else, let's close this brace. Else, available tickets equals whatever are the tickets that are on sale. And finally, let's print how many tickets are available. So we can say available tickets equals available tickets. Now look at this. We've got an error here. It's saying, okay, I cannot implicitly convert type int question mark to int, meaning there is no implicit conversion between a non-nullable type and a nullable type. Okay, we have to be explicit about the conversion, and one way to do that is simply say dot value. Dot value, if you look at the IntelliSense, it returns a non-nullable counterpart, an int. You look at that, int without a question mark. So that's one way to do that. Or you can use the cast operator. We will talk about implicit and explicit conversion in another session in detail. So you can either use this conversion. Okay, what we are doing is, okay, this is a non-nullable type. If you look at this tickets on sale, it's a nullable data type, but an int without a question mark is a non-nullable data type. So we are forcing non-nullable data type to be converted, nullable data type to be converted into non-nullable data type and assigning it to this variable. Okay, so if I go ahead and run this, obviously since tickets on sale is null, available tickets will be 0. But on the other hand, if you initialize that to some number, maybe 100 tickets on sale, obviously available tickets will be 100. So what's going to happen here? It will check, okay, tickets on sale, is tickets on sale null? No, it is equal to 100. So it comes to the else block. Okay, tickets on sale, value is 100. It will convert that to non-nullable data type integer and stores it in this variable. And finally we print that out. Okay, now look at this. If it is null, is 0. Instead of null, we are initializing that to a default value because this cannot hold null, this variable, because it's a non-nullable integer data type. Okay, now do we have to have so many lines just to do that? If it is not null, use the value that is present and available in tickets on sale. Otherwise, use some default value. So do we really need to have these many lines of code just to do that simple thing? No, not really. That's why we have this null coalescing operator, which we can make use of. And the way we do that is pretty simple. You can get rid of all these lines, and you can simply say int available tickets is equal to tickets on sale question mark, that's your null coalescing operator, and whatever is the default value that you want to initialize this variable with in case if this nullable data type is null. Okay, so what this line is doing, it's pretty simple. If tickets on sale is null, then use this default value. Otherwise, use the value that is present inside this variable. It's as simple as that. So it's just one line. So if you go ahead and run, the behavior will be the same, except that instead of using if and else, we are using the null coalescing operator, which is very simple to use. So this is without null coalescing operator, and this is with null coalescing operator. So you can see the difference, the number of lines has been reduced. So that's it. Thank you for watching. For more resources, you can refer to these things on the slide. Have a good day. Bye bye.